Thanks, Eric. Thanks, everyone, for being here. It's been a really amazing conference so far. I'm here to talk to you a little bit about my project, estimating environmental footprints for US states and some of the theoretical frames I'm hoping to employ, thinking about decoupling, offshoring, and overshoot. I started my PhD around a year ago at Madula University, but I think the project really started a year before that, 2 years ago, when I started as the research and data lead for California Donut Economics Coalition, researching indicators, looking for indicators on the state level and realizing there's a real lack of consumption-based indicators on the state level. We know really well, thanks to the work of Dan and friends, about most of the countries in the world. We have these consumption-based indicators linked to the donut framework. But yeah, for the states, I felt there was still something missing, especially when you think of states like California, the 4th largest economy in the world. Now it just recently moved, of course, measured imperfectly in GDP, but still says something about the size of the economy and the magnitude of the impacts. So yeah, when thinking about, I think also of the top 10 states, maybe 5 or more of them could be in the top 20 nations. So, and also a lot of policies are made right on the state level. It's not only about the national context. So some important things that I thought it's important gap to fill. Oh, I guess now I'm talking to the speaker. Can you guys hear me when I don't use the speaker? Is that okay? Yeah,
I think
awesome.
you should first.
You think I should? Okay. Yeah, sure. Feels a little uncomfortable. I will do my best. So just a little bit of what we'll talk about today. Some of the models I'm working with, I didn't build any of these models myself, but I am doing quite a bit of analysis and some tinkering with them. They're produced mainly by the EPA, the Environmental Protection Agency. So there's the national model and then the state models that I'm a little more interested in. I'll really quickly go over some of the theoretical background that I mentioned and discuss my own research questions. A little bit about how I interact with the models and some preliminary results. And then maybe some real-world applications and limitations, mentioning the CalDEC work again. CalDEC, California Donut Economics Coalition. So here are some of the major publications related to the models that I'm working with. We have the national models, which came first, and they have about 400 plus industry sectors. And they wanted to keep this a single region model so that actually originally relied on the domestic technology assumption, meaning they just assumed that imported goods had the same emission factors or whatever environmental factors as they did produce domestically. Since then, they've linked with XIO base, so producing novel emission factors for imports based on the percentage of imports and the impacts in those countries. So in a way, improving it, but keeping it as a single region model. And then in order to produce the state models, they produce a 2-region model of that single region model. So you break down the impacts by the state of interest, by the rest of the US, and you can also get a rest of the world category. Yeah, and so these first models, you can see around 15 different environmental extensions, and those are relying still on the domestic technology assumption. Then they've improved it for greenhouse gas emissions to do away with that. But we'll talk a little bit more about that when we get into the models. Very quickly, because I think we've all heard a lot about this, one of the main frames and buzzwords here, which I think is really important, and I'm glad it is, and it's informing my research as well, is this idea of offshoring, cost shifting, and unequal exchange, semi-related but distinct concepts. So we have maybe some of the original studies over here on the left showing how emissions are reappropriated when we consider consumption-based rather than territorial emissions, predictably moving from here in this case from China or OECD to non-OECD, or from China to the US. And then of course Hickel and Callis used some of these same graphs to argue that maybe green growth is not possible or not going so well, or at least not at a rate that we need it to. Also here, Choi et al. Linking the cleanup of US manufacturing to pollution in China, and accumulation by pollution over here by De Maria and colleagues, drawing off the accumulation by dispossession framework. And then more into the unequal exchange, the way global north economies maintain themselves and continue to grow by expropriating land, labor, and resources from the global south, and some very interesting new work on that. Christian Dorninger is one of my external advisors, so shout out to him, and thanks for him for wanting to get involved in this project. Oh, I wasn't using the mic again, I'm sorry. No, it's okay, I'll try. Moving on, the second frame that I'm thinking about is decoupling of economic growth from environmental impact, something we've probably heard a lot about in the past, but some of these meta-analyses have pointed out that there's really a lack of emphasis on the subnational level, on regional scale, and also using multiple indicators. So I'm trying to address both of those research gaps in a way with my study. And finally, thinking about the environmental footprint family and the absolute sustainability assessment, which is something that Dan and his colleagues did in their paper as well. I thought it was really nice. I'll have it on the side in a minute. But really thinking rather than just about relative sustainability, are we doing a little better than last year, thinking about these absolute limits. And for me, what makes the most sense is the allocation on a per capita equity basis. Of course, we can talk about the historical inequities there, but when they already show inequities so strongly, I think it's a strong enough argument we have here when we just take the per capita equal distribution. And so that's the approach that I think I'll use most likely for my study, but maybe complemented with some other more historical allocation methods as well. And as I just mentioned, the work that I think is really inspirational to me, these two papers which came out that sort of did this all and brought it together on the state level, the social shortfall and ecological overshoot of nations, and then before that, the good life for all within the planetary boundaries, down here of course. But then another important addition, I think, is the work of Tian et al. Over here, which then breaks, it's looking globally rather than at nations, but it breaks it down by wealth dectile and shows which income group is most responsible for ecological overshoot. Another interesting paper. I'm hoping to combine the input-output I'm working with survey data to get some of this disaggregation on the state level as well, not just have an average for the state of California, right? I think I've maybe already mentioned it, but just to go over it a little more formally, the research gaps and the questions. So a few studies focusing on the subnational level and considering multiple environmental footprints, some that have sought to do that to some extent in the US that I'm drawing from, listed here. So how are environmental footprints distributed between and within US states? What insights can this provide into offshoring, decoupling, and overshoot on the subnational level? And how has this changed over time? These models now go from 2012 to 2020, and they're expanding them up to 2023. And I'm also really interested in what has been the impact of policy on these trends. So could I combine this quantitative data I have with a policy analysis of the different states and see how that's maybe impacted the trajectories over time, what sorts of policies they're instituting. Specifically, maybe looking at some of the larger states, which I'll show here in a minute. Very quickly, how I'm interacting with the models. You can download some of them for Excel. Others you have to do with R. I've been getting relatively good at this. So the way they release them is they don't actually show you any of the results. You have to be able to do some coding and some calculations to get the results, which in a way is kind of nice for me because I'm not doing nothing with the models. So one example of that is taking like the emissions factors for each, those are the 15 extensions they have there, and then for each of the 70, I mentioned in the national model, they have 400 industry sectors. In the state models, they only have 70, or 73, I believe. So a different emission factor for each one of those 73 sectors that you can then multiply by the consumption complete vector and add together to get, well, you do it a bunch of different times and you get something like this. So for all the different indicators that they have available, you'll notice they're not only environmental indicators, there's some socioeconomic ones as well. But here I gave some basic calculations, so consumption and production per capita, the percent which is offshore, the percent overshoot comparing to the planetary boundaries, which I drew mainly from Sala et al., which was mainly drawing from Bjorn et al., maybe some studies that people are also familiar with here. Yeah, and then we can also think about some of the indicators that are maybe obviously missing from here. Something that I would like to include is the human appropriation of net carbon reduction. Materials and energy would also be very interesting and something that some of my advisors are working with, so hopefully we can have some ways to incorporate that. Here's some visualizations of what we just saw. But here we have the 10 largest states: California, Texas, New York, Florida, Pennsylvania, Michigan, North Carolina, Georgia, Ohio, and Illinois. And the difference between production and consumption based, in this case, just greenhouse gas emissions in 2020. And maybe kind of interesting to point out, Texas is the only one that had lower consumption-based emissions than territorial emissions, and maybe that's an interesting thing to talk more about later. Another here just for California, the difference between production and consumption-based indicators, and I highlight freshwater withdrawals as the main one, which is lower in the consumption-based than territorial. Maybe it makes sense when you think of California as a very large producer of agricultural goods and exporter of these agricultural goods, maybe embodied water there. And just to mention, these are all still relying on the domestic technology assumption and using version 1.0 of the state models. Here we get into version 1.1 where we include those emission factors derived from XIO waste to represent a little bit better the production in other countries. And so here we have territorial and consumption-based emissions for the 4 largest states over time. I decided to leave out 2020 because it's sort of a dip due to the COVID, which doesn't correspond with the rest of the data. But I also put some arrows here because the trend line is not so clear to see. But for example, California, the consumption-based emissions were increasing over the time period in total, not necessarily every year, but from 2012 to 2019 they increased. I should have probably put the percent change as well, but if you want to come and ask me about it after I have the spreadsheet, then we can calculate it quite easily, I think. So apologies for that. But interesting right away, I think, for the 2 democratic states on the left, we have rising consumption-based emissions and lowering territorial emissions. Also important to point out that these 2 territorial emission inventories were done by the states themselves. Both New York and California are democratic states that have had quite a lot of policy directed in this area and have been producing their territorial emission inventories throughout the study period, whereas the Republican states have not. Well, but you actually, it's interesting to see that for the Republican states, actually both of the emission categories were falling over the time period. So maybe it's an impact of what we're measuring and what we're trying to reduce, impacting what is actually being reduced. So something already a little bit interesting there. And again, I mentioned how Texas has higher consumption than territorial-based emissions, so maybe even some unequal exchange between states. That I also, something that, of course, I'm conceptualizing unequal exchange more between the global north and the global south, but maybe even within US states, there's some unequal exchange going on. Trying to remember if there's anything else I want to say on this slide. Yeah, one other interesting thing to point out, as I mentioned, so we're here dealing with California's territorial inventory created by the California Air Resources Board, and we see that territorially their emissions have been going down over the study period, and we all think of California as a very green state. But I think it's a little interesting that when we take, over here, it's pretty much the same figure, but now we're looking at the territorial inventory, which is conducted by the EPA, and it's consistent with the national territorial inventory for the United States, and here we actually see that emissions in California are rising over the study period. So they have a discrepancy between what the EPA is finding in their territorial emissions and what California Air Resources Board are finding in their emissions inventory. So I haven't looked into that too much yet, but I think it's something a little bit interesting to think about right off the bat. Yeah, so some additional time series we can produce from that version 1.1. Yeah, I think not too much more to say here. Another thing we can do is think about how the distribution of impacts by sector and region. So I mentioned we can split it by the US, the rest of the US, the state of interest, and the rest of the world. Something kind of jumps out to me right away is that we have the manufacturing sector as far and away the largest emitting sector, whereas in the territorial inventory we always see transportation. About 40% of emissions in California from transportation in the territorial inventory. A couple of reasons for this. One is because you can see food and beverages is included in the manufacturing sector here, something that maybe we don't typically consider as manufacturing, but could make sense from the input-output perspective. And also we divide the household emissions, household mobile, those would be the emissions from households burning fuel in cars, but we divide also like the transport and storage of goods separately from that. So normally in the territorial inventory, when we start transportation, we would see those two combined, I think. So maybe interesting also to compare this to a territorial inventory. Yeah, those are all the ones I just mentioned. Another interesting one is how low the emissions are from agriculture here, and I'm not 100% sure about this. My guess is that because this is a consumption-based inventory, all of those emissions from agriculture were reallocated to their final product, like food and beverages in the manufacturing sector, would be my thought. 2 minutes, perfect, yeah, thank you. So wrapping up now and mentioning my group, my team, I mentioned that I'm working for California Donut Economics Coalition, and we published a data-heavy report a few months ago. We were able to use many of these indicators. Maybe some of you are familiar with the donut. They try to include both the local and the global lens, and we tried to do this specifically for the ecological sphere, where we had one indicator each for the local, what's going on in California, and one more for the global. So consumption-based indicators from USIO were very useful in that regard. And we have a second installation of this report. I mentioned this was very data heavy, and we've been working with reviewers and producing deep dives, like section reports that go a little deeper into all of the indicators that didn't get included and some other areas of consideration to go along with the more data heavy one that we put out. So look out for that in the next couple weeks. And I'm part of the research team, but we have some other sociocratic circles like that are more involved in policy, more involved in local donuts at the city level, more involved with the education sphere. So I'm actually not living in California anymore. I used to, but now I'm living in Vienna doing my PhD. So still involved with the research, but happy to connect anyone if they're interested in hearing from some of those other people on the team as well. Current limitations and areas I'd like to explore further. I think I already mentioned that it's not really linked with survey data, so I would really like to combine it with consumer expenditure surveys to get some of this disaggregation on the state level within states. No consideration of provisioning systems to enable social well-being, no policy or cluster analysis. I would like to at some point combine with social indicators. I probably should have mentioned at the beginning, this is more of a broad presentation of my entire PhD research thinking about going forward, not a specific paper that I focus on, so you probably see 4 or 5 different papers up here on the screen right now. Yeah, I think I don't have to go into all of the other limitations. We can just wrap up, and feel free, hope some of you would like to get in contact. Thank you so much. Great.